Alright, so today we're going to be going over the exam 2. Basically, I'm just going to work through the exam. The questions do come at me, come at each one of you in a random order, and so since I am in a student preview mode, that's how they'll come at me. So the order of the questions, you see me go through them, will probably not match the order that you went through them, but the problems themselves will be the same. So with that said, let's go ahead and begin. As you recall, there was a 50-minute time limit. That will be true for exam 3. This test will save automatically when the time expires, so some of you ran into that. That will be in place next exam. One thing that will not be in place is the forced completion. That was if you accidentally exited out of the browser, or if, say, your computer shut down, it would go ahead and submit the exam. I didn't really like how that was going, so exam 3, forced completion, will not be an option that is activated. So having said that, let's go ahead and begin. But the exam will submit automatically once time expires. That will be a thing, but just if you exit out of the browser, it's not going to end the exam. Alright, so actually I want to keep that open. Let's look at question 1. We've got x cubed times e to the x. Alright, so let's go ahead and show this. X cubed times e to the x. That's a product rule problem. We have x cubed times e to the x, and we're taking the derivative of this guy. And so, we just take the derivative of the first guy followed by the derivative of the second guy, just like we've been doing this whole time. And so derivative of the first guy is 3x squared times ex plus x cubed times the derivative of the second guy, which is just e to the x, right? So kind of, for clarity, that one is the derivative, and then there's the derivative there. Okay. Let's go ahead and do a better tick mark there, all right? All right, so we notice that we can pull out a few numbers. We can pull out an x squared and an e to the x. And so that's going to leave us with 3 plus x. All right, so let's go ahead and check our answers, choices. All right, so first one is clearly a red herring. Next one is just not a real choice. There we are. Answer choice is the last one, D. So we go to the next one. X squared times natural log of x. All right, this is another product rule problem. Okay, and I'll just alternate my colors so that way it's kind of easy to see what's from the previous problem. Okay, and we're taking the derivative again. Product rule, first guy, then the second guy. So we have 2x, natural log of x, plus x squared times 1 over x. All right, and here's the derivative of the first guy, and then the derivative of the next guy. So this simplifies to 2x times natural log of x plus x. All right, and we can do some simplifications. We can pull out the x, and so we're left with x times the quantity 2 natural log of x plus 1. Note that we can take this 2 and move it up to there, and so we're going to have x times the natural log of x squared plus 1. So let's go back to our answer choices. right? And it looks like that first guy is the correct answer, and the rest of them were either just red herrings or just flat out wrong. All right, so next question, question 3. Cosine x plus x squared, you just apply the derivatives of both of them. The derivative of cosine is negative sine. The derivative of x squared is 2x. So we just go through our answer choices. It looks like that last one is the right choice. So let's go ahead and move on. And again, the derivative of cosine, that's just one that you need to have memorized. All right, so we've got a graph of y equals f of x here. And then we have that g of x equals x. And we want to know we have the derivative of the product of those two functions. What happens when we're at x equals 5? So I want you to notice something about this graph. Whenever x equals 5, right, f prime is going to equal 0, right? Because if you were to draw a tangential line, it would be just a flat horizontal line right here. And so that has a derivative of 0, right? So f prime at 5 equals 0. So we know f prime at 5 equals 0. All right? And if you go back to the problem, you can see that f of 5 equals 1. So those are two things that we know. And then we know, of course, that g of x equals x. So that's all of our known. So now we're trying to find the derivative of f of x times g of x. And so that's simply f prime at x, g of x, plus f of x times g prime at x. All right, good. So we've got all that. Let's go ahead and, we can see, we obviously know what g of x equals right here. And then note g prime of x equals 1. So let's go ahead and simplify. So we've got f prime at x times x. Plus f of x times 1. So we'll just leave the 1 off, so that's good. All right, so what are we really after? We're really after what's going on when we get to 5. So we have f of 5 times g of 5 prime. And so this is just f prime at 5 multiplied by 5 plus f of 5. All right, so f prime at 5 given there. F of 5 at 1. Oh. Sorry, I should have wrote f of 5. There we go. F of 5 right there. All right, so f prime 5, well, that's 0 times 5 plus f of 5, which is 1. 0 times 5 is 0. So the answer is 1. So let's go here. Look at our answer choices. Oh, this one we'll just type in, sorry. 1. And no decimal places. And yeah, let's go ahead and save answer. It does automatically save the answer if you go to the next, but if you want to hit the save button before going further, that is not a bad idea either. Okay. All right, so next one. This is a chain rule problem. Right, we got one function stuffed inside of another. All right, so sine of e of x over 1 plus ex. All right, so again, we've got sine ex over 1 plus ex, right? And we're taking the derivative of this guy. All right, so first thing we got to do is take the derivative of that inside guy right there. That's a quotient rule problem right there. And so we've got EX times 1 plus EX minus EX times EX all divided by 1 plus EX quantity squared. Okay, let's make sure we understand this. We got an e to the x, right? Derivative is right here in yellow. And then we got to take the derivative of the bottom, and that is right there. And of course, we do the bottom squared. And so we're clearly not done, right? That was just the derivative of the inside part right here. All right, so what we're going to do now is take the derivative of the outside part right there. So derivative of sine is cosine. So we got cosine EX over 1 plus EX. And now all we have to do is reduce the top. Let's see here. It looks like we can factor out an e to the x. And so we have 1 plus EX minus EX. So that's just going to be multiplied by 1. So we'll just ignore it. And then at the bottom here we got 1 plus EX quantity squared times the cosine of EX plus 1 over EX. Right, okay. Alright, so let's go ahead and see our answer choices. Okay. And it's tempting to pick the first one, but you might notice in that denominator that you see, right here, there is no square term. That one is wrong. Be on the lookout for that one. This one, you might notice that the derivative was taken on the inside, but it was not brought to the outside. Remember, the inside function stays the same. You only multiply it by the derivative, so that one's wrong. This one, e to the x over 1 plus e to the x quantity squared. That's the correct derivative. It is on the outside like we want, and it is being multiplied by the derivative of the outside. Inside function is good, and so we go ahead and check this one. And you might notice on this guy, everything is pretty much appears correct, except that when you would have applied the function, you would have, if you had done a plus instead of a minus, you would have ended up here. So you had to make sure you use the formula correctly to get to the right one. This is the right answer. Okay, let's move on. All right. So here we've got e times e to the x minus 1 plus 3. This one's actually not too terrible. Let's go to the here. So we've got e to the x minus 1 multiplied by e to the x plus 3. And we're taking the derivative of this guy. Well, note that right here, I'm sorry, this is just, there we go. Right here, when you multiply these through, you're just going to get e to the x. So you end up with e to the x plus 3, and we're taking the derivative of this guy, right? So answer is simply e to the x. There we go. Save answer, move on. Alright, so this one just kind of, what I'm testing on is make sure you know how to work with exponents. So let's go ahead and write this one out. Alright, so again we're taking the derivative of this guy. Go ahead and rewrite everything in terms of their exponents up. So this becomes x to the negative 3 plus x to the 1/4 power. Beyond that, just use the power rule. Negative 3x to the negative 4, right? Because negative 3 minus 1. And then over here, plus 1/4 times x. And then 1/4 minus 1 is negative 3/4. All right, so there we are. There, that's it. That's our answer. so let's check our choices. Let's see here. Alright, so answer choices, it's going to be the third one. Let me go ahead and show you why, because it is in a slightly different form. So this is going to be negative 3 over x to the fourth plus 1/4 times the fourth root of x to the negative 3. Okay, and so which matches our third choice right there. Okay, so that's the answer that you should have ended up at. I'll test you a little bit to make sure you were current on your exponent rules. All right, next one. All right, so this one you just apply the power rule on both of them. You note that we've got an e in the first term. The e is simply in the exponent, so we're going to minus 1. And so the correct answer is going to be this guy right there. Okay, next question. All right, so this is a quotient rule problem. And so we got e to the x over cosine x, and we're taking the derivative. Again, quotient rule, so we've got e to the x times cosine x minus e to the x times negative sine x over cosine of x squared. All right, and so just kind of make sure you're seeing everything properly, put those highlights in. And so note we got minus a negative, so that's going to become a positive. So in the next step we can see we can factor out an e to the x, so we simply have cosine x plus sine x over cosine squared x. So let's check our answers here. All right, so looks like we didn't have to pull out that e to the x to get to the, oh, well, the bottom is not squared, so can't choose that one. Third one almost looks right, except we've got a minus, and so the correct answer is going to be that one right there. Okay, so next question. An 8-foot ladder is sliding away from my wall at 1 foot per second. How quickly is the ladder falling down along the wall? Alright, so recall on this one. Okay, so we've got an 8-foot ladder. You know, you always kind of want to draw the picture to be able to see it. 8 feet. And so we've got, you know, it's sliding down this way, which means it's sliding out. It's a rigid ladder. And what was the other given? It was sliding away from a wall at 1 foot per second. Okay, so that makes things nice. So we've got 1 foot per second, and we'll just call this v. And so what do we know? We know that 8 squared equals x squared plus y squared, where x is the position here, and y is the position right there. All right, and let's go ahead and take the derivative of this guy here. Remember, it's going to be as the related rates, we're going to be doing treating each function as a function of time. 2x times x prime plus 2y times y prime. And so let's go over what we know. We know that x prime is 1 second. And we can also factor out the 2's, since over here it's 0. And now we simply solve for y prime. So we have that y prime equals x divided by y. Okay, and so let's go back to the question for a second. So we need to get in terms of x. So let's go ahead and of course y prime is the same as v. Alright, so we got x here, and we want to get a term for y now. Let's do similar. Let's go with this one. So solve this for y, and we will get y equals the square root of 8 squared minus x squared. Note that we are not taking the positive or negative, only the positive, because the negative would imply that the ladder has fallen through the ground. It is now plummeting through the crust of the earth. So 8 squared minus x squared, there we are, that's it, that's our answer. And looks like correct answer choice is, wait, hold on. Oh, forgot to put the negative here. Negative, negative, there we go. The correct answer choice is going to be right there. Okay, save answer, next one. Alright, so again, what is the cosine of the inverse cosine? Well, they're inverse functions of each other, so they go away. So this ends up being simply x cubed plus the inverse sine. Right, so we should have 3x squared as the first term. Alright, so this one looks like it's a contender. This guy also looks like a contender, and so is this guy. The derivative of the inverse sine is not inverse cosine, so we can immediately throw that one out. And so it is between this one and this one. We note that they have very similar formats, but the derivative of the inverse sine is positive, so there's our correct answer choice. Inverse trig functions are ones that you should have on quick recall. This was an open resource exam, so it's not a bad idea to have them quick and handy. Alright, natural log of x over e to the x. This is a chain rule problem. Furthermore, natural log, so you just take the derivative of the inside function and divide it by the original inside function. So let's go ahead and work this out. And that was, and so our answer is simply going to be, x over e to the x goes in the bottom. That's the inside function. Now we take the derivative of this. Note it's a quotient rule problem. And so we have e to the x minus x times e to the x all over e to the x squared. Right? That's what it ends up being. We can simplify this rather quickly. So we multiply, well, first this top fraction here, we can factor out an e to the x, and so we end up with 1 minus x over e to the x divided by x times e to the x. So we can kind of factor these two guys out. Let me go ahead and write that out because I want to make sure everyone can see it easily. This becomes 1 minus x multiplied by 1 over e to the x. And this becomes x times 1 over e to the x. So it should be very clear that those cancel. And so we're left with 1 minus x all over x. Distribute that guy, we get 1 over x minus 1. Okay, 1 over x minus 1. So let's go over here. 1 over x minus 1. There's our correct answer choice. Let's move forward. Alright, find the critical numbers for the following function. So critical numbers occur when the derivative equals 0, so we need to take the derivative of this function, 3x squared minus natural log of x. All right, so first we want to know what is f prime equal. And so we have 6x, that's the first one, minus 1 over x, and now we're going to set it equal to 0. So we've got, we'll just call, instead of writing x, we're going to write c. 6c minus 1 over c, where c stands for the critical number, equals 0. You can see already that one critical number is 0, right, because of this term here. And now let's go ahead and multiply through by c to try and find the other one. 6c squared minus 1 equals 0. Okay. Sorry, looks like I wrote this down wrong. That should be a 3 right there, making this a 3 squared. Okay, good. All right, so fix that, fix that. All right, so let's go ahead and work this through. So we've got c squared equals 1 over 3 squared. Take the square root of both sides, and then c equals positive or negative 1/3. There we go. And that's it. That is the answer. So let's go ahead and come over here. There's our correct answer choice right there. All right, let's go ahead and move on. Time is ticking. Below is a graph of the derivative of f of x. That is, we're looking at a graph of f prime. Select all the critical numbers. All right, so all we got to do is look at this guy and see where the graph crosses the axis, because that's when it'll be 0. And so we have, 1, 3, 7. And so we go 1, 3, 7. Okay, awesome. Make sure it's saved. It is. Good. Let's move forward. All right, here we go. This is a chain rule. The derivative of the square root of 5x plus 1. Let's go ahead and work through this one. All right, and we're taking the derivative. Let's make sure I got that down right. Yep, good. Is it minus or plus? Oh, plus, okay. All right, so let's go ahead and run through this. Derivative of the inside is simply 5. And then the derivative of the outside is going to be 1/2 times 5x plus 1 to the negative 1/2. 5 times 1/2 is 2.5. Right, that's 2.5, not 2 times 5. And this is all over the square root of 5x plus 1. And that's one form right there. So let's go ahead and take a look. Again, looking for... Alright, so first one is not right. Second one, we did not handle the 1/2 properly, so that one's not right. Alright, there's that one. Here we go. That is the only sensible answer. Let's move forward. Alright, use linear approximation to estimate the sign of 0.1 to 1 decimal point. Alright, so we're looking for sign of 0.1. Alright, so first we need to come up with our linear approximation, and remember that is going to simply be, f of a plus f prime at a times x minus a. Alright, that's the playbook we're using right there. We're going to use a equals 0, and we're going to use an f of x to be sine of x. So therefore, f prime of x is simply cosine of x, and then f of 0 equals 0, and f prime at 0 equals 1. All right, so our linear approximation is going to become a very simple to work with formula very quickly. And so L of x equals x minus 0, so it's simply x. So L of x simply is, L of 0.1 is simply 0.1. There we are, that's the answer, 0.1. So let's go through these. There it is right there, positive 0.1. All right, save answer, move on. All right, sine x, tan x. This looks like it's simply going to be a product rule problem. All right, and then we're taking the derivative of this. Derivative of sine is simply cosine multiplied by tan, and then plus sine times the derivative of tan, which is simply secant squared of x. All right, so tan is sine over cosine, so go ahead and write that in. Now that's the same as sine x over cosine x. So you can see cosines are going to cancel out. And so you're left with sine of x. And then secant squared is the same as 1 over cosine squared. So we can take one of those cosines, put it under sine, so that's going to become tan x multiplied by secant x. So sine x plus tan x secant x. Let's check our options here. There it is, right there. Last one is the choice. So in this one you had to kind of play around with the trig just a little bit to get to the right answer, but it was not impossible to do. So let's go ahead and move forward. The natural log of the cosine of x, so this is again, you put the original function in the bottom and put the derivative on the top. So let's go ahead and do that right now. All right, we're doing the derivative of the natural log of, what was it again? It was cosine x. I don't know why it just occurred to me that I could do this, but here we are. All right, so now this thing is covering up. Okay. All right, so we put the inside guy in the bottom, take the derivative of cosine, that's negative sine of x, that becomes negative tan x. So here we are, there's our answer there. Where can I submit that? There we go. Was it saved? Not yet. Okay. So moving forward. Alright, so this one's kind of a fun one. Let's go ahead and go through this. Ax plus b is simply a quotient rule. So ax plus b, derivative of that is simply a. All right? And then multiply by the bottom, cx plus d. And then minus the top guy, multiplied by the derivative of the bottom guy. And then don't forget that's all divided by cx plus d squared. All right. And now all we have to do from here is simply a little bit of reduction. We can actually look at it, and looks like we can already rule out two answers. the middle two answers, so it's only the first and the last that are contenders at this point, although things could cancel out, we'll see. Alright, so we have ACX plus AD minus ACX minus BC. And that's all divided by CX plus D quantity squared. And so ACX cancels with ACX, ACX minus ACX, so we simply have AD minus BC, and that looks like, right there, I'm just looking at those wrong, but that's fine, AD minus BC, yep, squared. Okay, yeah, so that's the right answer right there. So let's go ahead and move forward. Alright, so now we got tan x plus secant x, and so this is just take the derivative of both. Derivative of tan is secant squared x, and then the derivative of secant x is simply going to be tan x secant x. Alright, so we look for the one that matches. Let's see, secant squared looks like it's that one right there. Save answer, and then let's move on to the next one. The position function is given by this. We need to find the acceleration. Alright, so that's just two derivatives of this guy. So velocity is s prime t, and so that's simply going to be product rule, e to the t plus t times e to the t. Right, that's just product rule. We can factor out an e to the t so that we get 1 plus t like that. And so the acceleration function is simply the derivative of the velocity function. And so again, another product rule. Derivative of e to the t is e to the t. And then we've got e to the t times the derivative of 1 plus t, so that's 1. We can factor out an e to the t, and we will end up with 2 plus t. And so the answer is this guy right there. Okay. Saved already, good. Next question. Alright, so we got a function, we need to find the derivative now. And so this is a quotient rule. So derivative of the top is 1 times x squared plus 1, and then minus x times the derivative of bottom, which is simply 2x, and then we've got, the bottom squared. Okay. And just to kind of, for emphasis, this was the derivative of the top here, and there was the derivative of the bottom. Alright, so let's simplify this guy. So this is going to be, x squared plus 1 minus 2x squared divided by the bottom squared. Right, and so that simply becomes 1 minus x squared over x squared plus 1 quantity squared. Looks like that's the answer right there. Alright, cool. Let's see, save answer. And let's go on to the next one. Alright, so now we're on an implicit differentiation problem. And on this one, we're going to go ahead and first take the derivative of the first guy, that's cosine of y. Keep in mind y is a function of x. X is just a independent variable, so we need to make sure we have the inside derivative there via the chain rule. And then we've got a little product rule going on, that x times y. So derivative of x is 1, so we have 1 times y plus, alright, hold on, plus x times y prime. And of course the derivative of 3 is a big fat 0. Alright, so let's go ahead and group the y primes together so that we get y prime times cosine y plus x. We're going to go ahead and move this x to over here, y over there, so that we get a negative y, divide through, y prime equals negative y divided by cosine y plus x. Alright, and so it looks like that first guy is going to be our answer. Okay. Alright, so on this one, turns out there is a problem with the answer choices. I will be including these points on the curve that I'll be adding to this exam. So let's go ahead and write down the problem, and then we'll just go ahead and switch to full screen on over here so you can at least see how to work it properly. So inverse tan of x minus the inverse cosine of x. Alright, so f prime of x, and so when you take the derivative of tan, this is one that you just need to have a quick access to, and so that is 1 over 1 plus x squared minus, so a negative 1 divided by the square root of 1 minus x squared. Alright, awesome. And so note that we could, and we will, go ahead and make that a positive. There are a few tricky things I could do to make sure that you were up to snuff. I could say 1 plus x squared, and then have the square root of 1 minus x squared divided by 1 minus x squared is one form of the equation. Alright, so I think that'd be good enough, unless you wanted to house them under a common denominator, in which case we would have a 1 plus x squared term here over a 1 plus x squared term here, and then do 1 minus x squared over 1 minus x squared. Right, multiply it through, and you'll end up with 1 minus x squared plus 1 plus x squared over the square root of 1 minus x squared all over 1 minus x to the fourth. So just make sure you're, by the time the final comes around, you're up to manipulating equations, because we don't necessarily know how the test is going to look yet, but it'll be pretty similar to what you've seen so far. So anyways, just wanted to kind of go over the different forms this could take. So again, there will be a curve in the exam. I'll be posting that probably sometime this weekend, and I hope everyone has a good time studying, or at least is getting something out of the course, even though we have switched to this online format. So anyways, have a good day.